You're welcome back to the tutorial. In our previous video, we arrived at this particular point, okay, where we've searched for about 50 templates for our modeling, okay, where we can build our model from. But before you build your model, there are certain properties of these models or these particular predicted proteins you must put into consideration before to actually know if they met or meet your criteria before you pick them. From what we can see, this is the sort, okay? It has the database has sorted them according to few properties or factors it considered necessary. The first one is coverage, okay? Coverage in this box is this blue portion, and as you can see towards the end, you see some unshaded portion, okay? This blue portion is simply telling you the similarity between your target sequence and this particular protein or this particular sequence you want to, or this particular model you want to make use of. So this particular blue portion, you can see covered greater percent of this particular protein, telling you that the similarity here is a bit high. As you go down, you may discover the coverage may start reducing. As you can see here, there are now some white portions towards the middle, telling you that the coverage or the similarity reduces as you go down the sort here or sorting here. After coverage, what I have is the GMQE number or value. We'll call this the quaternary, or what we call the quaternary model estimate, quality estimate. Okay. Also, we have QSQE. Okay, QSQE simply means our quaternary structure quality estimate, and we have identity, and we have method, and we have oligostate and ligand and the rest. Okay, this value here, okay, QMQE and QSQE, okay, has to do with what one. For instance, one value, if a value is 1, is perfect, it means the similarity is perfect or the model is perfect for your protein. But as you can see, you hardly get 1 telling you that the perfection cannot be 100 or the similarity cannot be 100. But from what you can see, we have up to 0.85 for the GMQE. I'll have 0.97 for the QSQE, which is actually very high similarity here. And in identity, we have up to 60.67%. Okay, some will tell you identity below or identity above 30% is very fine. Okay, identity above 30, whereas some will recommend 50. But in this case, we have up to 60%, 60.67% similarity in identity. Okay, but from 30% up, you can work with it and is acceptable anywhere. But the higher the percentage identity, the more similar the model is to your target protein. Then the method of extraction also, is very important here. Here we have X-ray crystallography. We can have X-ray, we can have NMR, like I've mentioned, we can have electron microscope and the rest. But most of the extraction method here is X-ray, okay? Which means it's good. X-ray is the best out of them all. Then, aside the X-ray, we also have the Armstrong value. The smaller the Armstrong value, the higher the resolution of the protein, okay, of the model you are using here. So any model less than, going down towards 1 gives you a better resolution. For instance, in resolution or in method of extraction, this one that has 1.8 is better than this one that has 2.2. But several other factors must have been included, to get this be the first one. For instance, the identity is also there. Then the QSQE value here is 0.97, whereas this is 0.91. Okay, so this could be one of the reasons why that was not picked. Okay, so this is what I have. Then aside that, I have the oligostate, is a homodimer, you can consider that, and then the ligand. So these are the few properties I can consider before I pick my value. Make sure your QMQE and QSQE value is good, okay, is high enough or is tending towards 1. Anything less than 0.5 may not be very good, or okay, some would say less than 0.3 may not be very good model for your what, for your target protein. So you put that into consideration. Then here we have this particular what, this up to 50 templates, like we said. We have up to 50 templates, like we said. So in our next step here should be to pick at least 5 of them, depending on the criterias or the factors you've considered here. You can simply what, click on what, the 5 of them, or 5 out of the 50, and build your model from. Okay, you can simply click the 5 out of the 50 and do what, and actually build your model from. So we simply check, we have checked this. Okay, we can pick this one, let's say. And remember, beside this name you see the what, the pdb value or the pdb code of each of these protein. That's this on red. Okay, if you go to pdb and type this particular value, it will give you this particular model or these proteins, okay, we're looking for here. Then this is one, I can leave this. Okay, let me select this. Okay, I can also select this. This is 3. I can select 4. Okay, and then I can select 5. Okay, I want to build my model out of this particular 5 models I've picked. Okay, these are 5 proteins with no structure. These proteins have their structure already. So what I do, I'll pick 5 out of this and what, and build my model. So I'll simply click on what, build model. Okay, is reading. Remember, depending on your internet strength, it may take a little time to load. Okay, it's trying to build a model. It's trying to build a